All right, review. Right here we have parallel lines. Only one pair, which makes it a trapezoid. But two equal legs make it an isosceles. I did that. Switch the letters. Isosceles trapezoid. Number two, one pair, two pair of parallel lines makes us a parallelogram. That's all we know about it. That's the most specific name we can give it. Right here, just quadrilateral. We don't know anything else about it. It just got four sides. 4 and 5, actually, we know it's a parallelogram, but with the 4 right angles, it's a rectangle. To be a square, which it doesn't even look like, all 4 sides would have to be equal. Now, number 5 looks closer to a square, but it's still, the top and bottom is a little bit longer. So this is also a rectangle, because we have opposite sides parallel and 4 90-degree angles. If all of these had a mark of 1 or 2, it would be a square. And then number 6, like number 2, opposite sides parallel, makes it a parallelogram at most. It's the most specific name. Now, very key here, parallelogram. All of these shapes are parallelogram. So now you got to look at the properties you know about parallelograms. Parallelograms have opposite congruent sides, which means they are equal to each other. So we literally just set them equal to each other and solve. So if I subtract x, 2x minus x gives me x. If I add 9, I get 11. And I can plug that in and check it. 2 times 11 is 22. Minus 9 is 13. 11 plus 2 is 13. Check your work if you've got time. All right. Opposite angles are congruent to one another. So I just say this one is the same as this one. Subtract 5, I get 45. Divide by 15, x is 3. Now, parallelograms, as we said above on number 7, have equal sides. Opposite sides are equal, congruent. So, x plus 1 equals 8. X equals 7. Oh, I forgot to say on the previous one, you could plug this 3 right back in here. 15 times 3 is 45, plus 5 is 50. Plug this 7 in right here. 7 plus 1 is 8. Check your answers. Now, 10 and 11. Very special problems. Most common mistake is, oh, they're equal to each other. 10 is a little bit harder, but 11 is more obvious. Do those two angles on number 11 look the same? No. This is clearly obtuse. And this is a cute little angle. All right? Not as obvious on 10, but this one is obtuse. It's a little bigger than 90. And this one's acute, a little less than 90. Therefore, do not say 14x minus 4 equals 16x plus 4. That's a no-no. The biggest no-no there is in this one. And it's the most common mistake. Consecutive angles are supplementary. This one plus this one are supplementary, which means they add up to 180. And remember also, only angles add up to 180. Sides do not. So, combine like terms, that's 30x. Minus 4 plus 4 cancels, 180. Divide by 30, x is 6. And again, I can plug 6 in here and solve. 6 times 14 is 84, minus 4 is 80. So we know this is 80 degrees. 6 times 16 is 96, plus 4 is 100. 100 plus 80 is 180. They're supplementary. Take time to check your work. Same thing here. The acute one, love this board. The acute one plus the obtuse one add up to 180. So these two together make 140. If I subtract 140, I get 5x equals 40. And if I divide by 5, x equals 8. And again, I can plug 8 in right here. 5 times 8 is 40. 40 plus 8 is 48. So this angle here is 48. And if I add that to 132, I get 180. Now, 12. These two angles are opposite. They are both acute. So they are equal to each other. They don't add up to 180 because they're both the same type of angle. Look at the angles and see what they are, acute or obtuse. Now this one's a tricky one because you get an answer of x equals 0 and people think, oh, I must have done something wrong. No. If I plug in 0 here, 0 plus 65 is 65, and 65 is equal to 65. So kind of a trick one, throws you off, but it's fine. All right, now in this one, again, it's telling you it's a parallelogram. So we use what we know. Now KD is 16.6. That's this segment right here, 16.6. What do diagonals do? They bisect each other. They cut each other in half, which makes this 16.6. I label it before I even see what it's asking me for. Now, what's it asking me for? DM. Oh, just 16.6. But that way, if it had asked me for KM, I wouldn't have been thrown off and jump into saying 16.6. I would add them together. F to Z, what is that? That's this piece right here. It's 22, which makes this piece also 22. Now, what is the problem asking me? It's asking me for ZH, which is just the other piece, so also 22. Okay, CE is 14. Oh, watch. CE is this entire piece, 14, which means these two pieces are 7. Again, I label it before I even look at what it's asking for. It's asking for YE, which is just this piece here, 7. QZ is 12. That's this piece, 12, which makes this piece 12. What's it asking for? QS, the entire thing. So that makes QS 24. Okay, number 17 is a tricky one also. You got to pay attention. TX is not a number, it's an expression. TX, which is right here, is 11x minus 1. Just like I did before, I'm going to go ahead and label this 11x minus 1 before I see what it's asking for. Then it tells me that TV, which is this whole piece here, is 20x plus 2. That means 11x plus 1 plus the other 11x plus 1 is 20x plus 2. So we add these together and get 22x plus 2. Now, a little shortcut. You could have also started off by just saying 2 of these equals 20x plus 2. And that would have taken you here also. Just a different way of looking at it. Now, I'm going to subtract 20x. 22 minus 20 is 2x. I'm going to subtract 2 from this side. I'm sorry, my bad. That was 11x minus 1. So I got to go back and fix some stuff here. Whoa, did not mean to do that. Wrong size. Meant this one. These are all supposed to be minus 1. Sorry about that. So minus 1, which means minus 2 right here. I'm going to add 2 to both sides, which gives me 4. And then x equals 2. Now notice though, all these other problems, sometimes they ask for x, sometimes they ask for a segment. I needed to find x so I could find tx, which is this piece right here. So if I plug 2 in right there, 2 times 11 is 22, minus 1 is 21. So tx is 21. Make sure you're looking and answering what they're asking for. All right, WP, that's right here, is 4 plus x. I'm immediately going to label this 4 plus x. It then tells me PU is 2x minus 8. So actually, I need to go back and erase that. But at least I knew what I was doing. It's also 2x minus 8. So I set them equal to each other because they are the same thing. That's why I jumped to that conclusion before. So I'm going to subtract x from both sides and add 8 to both sides. X is 12. But that's not what it's asking me for. It's asking me to find WP. So I need to plug a 12 in right there and find out that WP is equal to 16. Okay, moving on. Next page. My next page, yours is on the same page. Okay, before I do anything, even looking over here to the left, I'm just going to label stuff. Now, with a rhombus, the angles are bisected, which means this is 59. And opposite angles in a parallelogram are equal, so this is 59. This will make your life so much easier in this problem, less confusing if you label first. Now, what is 59 plus 59? It's 118. This is good practice anyway. Now, this angle here and this angle are supplementary. So if we do 180 minus 118, we'll get angle on the outside. That's 62. So this is 62 and this is 62 degrees. Which means that the angles are bisected, each of these smaller ones is 31. And then, if I know this is 12, this is also 12. And that's all, oh, no, I can also label all these outside pieces 14. That's everything I can possibly label based on what I was given. The only thing I don't know is BE, ED, and BD. But I know everything else. Now look how easy it's going to be to answer these questions. BEC. So B to the E to the C. Well, remember, in a rhombus, these angles in the middle are 90 degrees. They're perpendicular lines. BCE. So B to the C to the E. Well, we already labeled that. 31. See how easy that is? AC, where's that? AC is right here, from here all the way over. Well, each piece is 12, so that's 24. That's centimeters. ABD. A to the B to the D. That's this angle right here. 59 degrees. AD, which is on the outside piece, which is right here, all of them are 14 centimeters. And last but not least, ADC. ADC is this entire angle 118. See how easy it was after labeling everything? We're going to do the same thing here, and then we're finished. So 24 and 24, opposite sides equal. 7 and 7. 12.5, 12.5. If this is 60, this is 30 because it's a right angle, which makes this 30 and that's 60. And because of alternate interior angles, this is 60 and that's 30. And this is 60 and that's 30. And just for the heck of it, right here I have a triangle, 60, 60, 60. Alternate vertical angles are equal, so 60, and that makes this 120. Okay? Everything is possibly labeled, that I could label. So let's go over here. HT. HT, that's the bottom right here. HT is 24. AT, that's over here on the right side. That's 7. HY, that's this part of the diagonal right here, just to the middle, 12.5. AH, that's the entire diagonal from here to here, so that's 25. MT, well, that's a tricky one. I don't know, because there's no numbers along that line. But remember, the diagonals are equal in a rectangle. Therefore, MT is also 25, which makes MY 12.5. HMT. So H to the M to the T, 60 degrees. And HTY. So H to the T to the Y, right here, 30 degrees. And there's your review.